Good morning, students. In this class we will discuss about packet switching and WLAN. Packet switching and WLAN. Take the page number 7. We had completed up to this Morse conversation and then we will start here. Jodi. The packet is similar to a letter enclosed in an envelope. Okay. The packet is similar to the letter. In letter, you know that envelope in the front page, in that we will give the from address as well as the to address also. So here the envelope has the address of the sender and receiver. Okay. Sender and receiver. So Teja is asking, what is the message? Why is the message divided into so many packets? Why is it not sent as a single packet? So she is asking why the messages has been divided into so many packets, why it is not sending as a single packet. So Moses is saying breaking the message down into packets allows the same cables to be shared among many users in the network. So here Moses is saying that breaking the message into packets because that same cable can be used by many of the users. Okay, by breaking the message into a small packets, so the same cable can be used by the many users. Okay, as a result the capacity of the network to accommodate simultaneous users is increased, so that the network capacity also increases. Okay, so here breaking the message into small packets that allows the same cable can be used by the many users, so the network capacity also increased. Jodi, are the packets numbered? After all the packets are received by the destination computer, they get compiled into a complete message. Here she is asking that packets are numbered. Okay, the information, the data is divided into smaller packets. So the packets is numbered or not. After all the packets are received by the destination computer, they get compiled into a complete message. They will gathered and separate as a single packet. She is asking. Moses is saying yes, the packets are numbered. The packets are numbered. These are called sequence numbers. So sequence numbers means the packet is divided. The packet is numbered as 1, 2, 3. The first packet as 1. The second data is packet as number 2, and the third data is packet as number 3. So this is sequence number 1, 2, 3, 4. The packet also has the information about the total length of the message. So each packet also has the information how much length the data is. Okay, so there is no confusions. So here packet switching in a data network. So here there are so many routers and also the packets. Okay, so what is router? It is a message transfer. Okay, it is just a message transfer. It forward the packets to the particular IP address. Okay, and it allows multiple devices to use the same network. What is router? It is a message transfer. Okay, it is used as a message transfer, forwarding packets to it will forward the packet to the particular IP address, and it also allows multiple devices to use the same network. Okay, it allows the multiple devices to use the same kind of network. Here many paths may be used for a single communication as individual packets are routed to a destination. Okay, there is no any fixed path. You can use any of the path. It can be sent on this way or can send on this way. There is no fixed path. You can use any of the path. Okay, many paths means if for example this is your server, you need to transfer the packets. There are how many packets? 1, 2, 3, 4, 5, 6, 7, 8 packets. 8, 9, 10 packets are having. So I am sending this packet via this way. Okay, here first this will send to this router, and then it will send to this router. At last it will send to the server. Okay, at last it will send to the server. This is one way. If I need to send this packet, I will use this way. Okay, I will send this way. From here I will send to this router, and next to this router, and then next this router, and at last I will send this to this server. Okay, so we can use any paths, okay, for a individual packets. No fixed path is established. So I already told that there is no fixed path. You can use any of the path. So packets are routed according to the best path available at that time. So it will choose which path is better. So it will choose which path is better. Then it will send that packet to that particular path. Prior to transformation, each communication is broken into packets which are addressed and numbered. During peak period, communication may be delayed but not denied. Okay, so before the transmission, each communication or a data or information is broken into packets which are contain the addresses, source address, destination address, and also it is numbered as 1, 2, 3, 4. During peak period, communication may be delayed. If the network is busy, the communication may be delayed but it not denied. Okay, it will surely send your message. It may be delayed but it not be denied. Okay, at the destination, packets may be reassembled into order according to the sequence number. At last, the server will get all the packets. Okay, the server or a computer, anything, it will receive all the messages and it numbers it as sequence number, and it will arrange it by using the sequence number like 1, 2, 3, 4, 5. It will arrange and send it to that particular person. Okay, particular IP address. So here these are all packets I said. So each packet has an source address, destination address, sequence number. So this is the header. What are the header? Source address, destination address, and the sequence number. At last only the information or the data. Okay, each packet contains source address, destination address, sequence number. Okay, so here packet. A packet is a formatted unit of data. It is a formatted unit of data, which means divided. Okay, the data is divided into packet. A packet consists of two kinds of data. A packet has two kinds of data. One is control information, which is also known as header. What are the control information? Source address, destination address, and sequence number. And user data, also known as payload. Okay, what is the data? Okay, what is the data is known as user data. It is also known as payload. The header provides the information the network needs to deliver the user data. So here the information is the destination address. So here we have the destination address. For example, source and destination addresses, error detection codes like checksums. Okay, error detection means it can be done before and after transmission that the data is free from errors. It is used to check whether the data has any errors or not. And one of the method is in error detection is checksums. Okay, and sequencing information. Sequencing means 1, 2, 3, 4. Here you have the source IP address, destination IP address, and it will check the error detection codes and then the sequence numbers. Okay, typically control information is found in packet headers and trailers which with the payload data in between. Okay, so here you have a header, trailers, and also the payload. Payload means data. Okay, then packet switching. A message from one computer on the internet to the another gets divided into packets before sending it. Okay, a data will divided into packets before sending to the other computer. Each packet is then transmitted individually and can even follow different routes to the destination. Okay, each packets will transmit in any way. Okay, it will go on this way or use this way. Okay, there is no restrictions to use any ways. The packets will go on transmit in any ways. Once all the packets forming a message arrive at the destination, they were recompiled into the original message. So once the packets will arrive at the destination address, then it will recompile the original message by using the sequence number. Such type of communication in which small units of data are routed through a network. So based on the destination address contained with each packet. This is called packet switching. So here the communication, here the small units of data which are packets, it will divide into packets or routed through a network. So it will transmit through a network based on the destination address contained with the each packet. Okay, based on the destination address, it will send to the destination IP address. Okay, this is called packet switching. So here you have some information about TCP or IP. TCP or IP. TCP stands for Transmission Control Protocol. Transmission Control Protocol, and IP stands for Internet Protocol. Okay, is a set of rules used to interconnect computers and communicate data on the internet. Okay, it is used as a communication device. TCP or IP is a communication device, as well as it will interconnect all the computers to each other and do the communication. Okay, by using the internet. TCP or IP specifies how packets are transmitted based on IP address and then routed to and received at the correct destinations. So here TCP or IP tells how the packets are transmitted, how the transmission has been happened based on their each of the IP address and then routed to and received at the correct destination. It will tell the way how the packets are transmitted and how in what way they are routed, and then also it will say how it receive at the correct destination. Okay, then network address. Network address serves as a unique identifier for a computer on a network. Each computer has a different network address. Okay, when we set up correctly, computers can determine the addresses of other computers on the network and use these addresses to send messages to each other. So if I have another computer's network address, then I can share the data to send data or to send the messages. Okay, so it is very useful for network address. Each computer has a different network addresses. By using this network addresses, we can share the data or to send the messages. Then hub. A hub is a networking device that provides the common connection point for multiple computers on a network. So in last class LAN also we have studied about hub. Hub is a device, networking device that have a common connection. Okay, common connection point for multiple computers. Okay, multiple computers can be connected to a hub on a network. Switch and hub are similar. Switch is a networking device that filters and forwards data packets between LAN segments. Okay, it will filter the data and then forwards the data to the destination address by using the LAN segments. Okay, here WLAN. Next topic is WLAN Wireless LAN, which means Jyoti is saying, I have seen laptops connecting to the network without a cable. Okay, we all know that a laptop can be connected to the network without the help of any cable. Okay, so in some places like airports and offices, cables are not required at all. Anyone with a laptop, smartphone or table can access the network. You have a smartphone, so we don't need any cable to connect the network. These are called wireless connection. These are called wireless connections. Without the help of wired connection, we can access the laptop, smartphone or tablet for a network. Okay, these are called wireless connections. Radio signals are used to connect a computer to the network. Here radio signals are used to connect to computer to the network. Here they are using in LAN they use a cable. Okay, network cable. Here they are using a radio signals to connect a computer to the network. A wireless antenna is built into the laptops to send and receive data. So in a laptop, smartphones or tablet, they are using a wireless antenna. Okay, in the laptop to send and receive the data. Similarly, the switch also has an antenna. Okay, the switch also has an antenna. for transmitting and receiving the data wirelessly, and this is called WLAN. WLAN stands for Wireless Local Area Network. Okay. So here WLAN, a LAN that uses radio signal to connect computers is called WLAN. So here in WLAN we use the radio signals. One type of commonly used radio signal is Wi-Fi. Okay, Wi-Fi is one of the commonly used radio signals. In a WLAN, a wireless switch with one or more two antennas, usually sticking out from the back of the switch, used for sending and receiving data to and from the computers. Okay, so here a wireless antenna is connected to the switch. Okay, to one or two antennas which is on the back side of the switch, used for sending and receiving the data. The range of wireless connection is approximately 50 meters. Okay, we can use that Wi-Fi or a wireless connection within the 50 meters only. Okay, computers and other devices capable of sending and receiving data wirelessly can become a part of a WLAN when they are within the range. Okay, within the range means within the 50 kilometers they can access that Wi-Fi and then they can use the internet. Okay, so for example, if I am in the Green Valley school, then there is a Wi-Fi connection in I am school, then I can access the Wi-Fi. If I came to the bus stand, can I use that Wi-Fi connection? No, I can't able to use that Wi-Fi connection because it is more than 50 kilometers. We cannot able to use the Wi-Fi connection. Okay, wireless connection or wireless connection. One example is only Wi-Fi. Okay, have you all got it? Thank you.